Act 1105, College Algebra, Chapter 4, Section 1. Section 1 and Section 2 deal with linear functions, whereas Section 3, 4, and 5 deal with quadratic functions. The chapter is, properties of linear and quadratic functions. All right, so first of all, we know, or should know, that a linear function is y equals mx plus b, which I have right here, where m equals the slope, b equals the y-intercept. Make sure you understand y-intercept is not y equals. That signifies a horizontal line. The y-intercept is an ordered pair with 0 as x. If it's a function, which all equations in linear form are functions, then we can write f of x equals mx plus b. Remember, f of x means y. So if we go straight to example 1, let's say we get f of x equals negative 3x plus 1. And the one thing I want to always remember is that slope is always a fraction. If I have a negative slope, I'm going to leave the negative at the top, or at the numerator's place. The denominator becomes positive. If it's a positive slope, they're both positive. It helps me move. Whenever I'm trying to graph it, I'm always going to plot the y-intercept, which is 7. So I'm going to go 7 on the y-axis, which gives me the point 0, 7. From that 0, 7, I'm going to go down 3, then over 1. Gives me a second point. I can draw my line. I'm done. So, make sure you understand that with slopes, or when graphing lines, you're plotting the y-intercept first on the y-axis. From that y-intercept, you move your slope to get your second point. Then you draw your line. Remember, you only need 2 points to draw a line. Example 3 over here deals with looking at linear equations and determining whether you have increasing, decreasing, or constant functions. All deals with a slope. If I have a positive slope, I have an increasing function. Negative slope, decreasing function. Positive slope, increasing function. Y equals a number as a horizontal line, so this is constant. Got to remember the formula for slope. It's the change in y over the change in x gives you m. The one thing you got to realize is that they're going to do it in function form. So they're going to have f of x2, which is really y2, minus f of x1, which is really y1, over x2 minus x1. So don't let the function form of y-intercept mess you up. This is still y2 minus y1 over x2 minus x1. One of the things that we could do is if we have ordered pairs, we can just look at the ordered pairs and determine if it's a linear function by finding the slope between two successive ordered pairs. Negative 2, 13, negative 1, 10. We do the slope formula, we get negative 3 as a slope. Then we do negative 1, 10 to 0, 7. We get negative 3. If we do all these slopes, we get negative 3. If we get the same slope for all our pairs of points, then this is a linear function. Here's an example of one that's not a linear function. Again, we're going to find the slope between 0.09 and 1.12. We get 0.03. We do the next ordered pairs. We get 0.04, next one 0.06. See how we don't get a consistent slope. So this particular set of points is not linear. And when we get into the quadratic functions, you'll see a test for determining if it's quadratic. Now we're just going to go through some word problems here. This is example 4 on page 285. It says book value is the value of an asset that a company uses to create a balance sheet. Some companies depreciate assets using straight line depreciation so that the value of the asset declines by a fixed amount each year. The amount of decline depends on the useful life that a company assigns to an asset. So suppose a company just purchased a fleet of new cars for its sales force at a cost of $31,500 per car. The company chooses to depreciate each vehicle using the straight line method over 7 years. So what that's saying is that the company has the ability to determine how long a piece of equipment is going to last. And the government gives them the right to depreciate that. In other words, take that amount off their taxes every year. So this company bought a bunch of cars for $31,500. They're figuring that the car is going to last 7 years. So you take $31,500 divide by 7, you get $4,500 per year. There's our slope. It says write a linear function that expresses the book value, V, of each car as a function of its age in years. So what happens here is we're going to have V of X, value, based on the age, which is X, equals negative $4,500. Remember, we calculated that negative $4,500 because the car is going to depreciate, which means it's going to lose $4,500 of value every year. The y-intercept is the original cost of the car. So you can see right here that negative $4,500 is the slope. It's how much the car is going to depreciate each year. $31,500 is the beginning price of the car. If we graph that linear function, we'd have to have axes. We'd have to have the y-axis at least go up to 31.5 and the x-axis go to 7. That's our maximum values. If we go to C, it says what is the book value of each car after 3 years? Well, what we're going to do is take this 3, because it's years, we're going to stick it in for x. Do the math, and we find out that after 3 years, each car is worth $18,000. That's after losing $4,500 a year for 3 years. Interpret the slope. Well, we already interpreted the slope. We know that negative $4,500 is the slope, and that's how much a car loses value each year. It says, where will the book value of each car be at $9,000? So the value, 9,000, is our y. So what happens here is we're going to stick the 9,000 in for y, or v of x. Subtract this 31,500 over, we get that 4,500x equals negative 22.5. Divide by the 4,500, and we find out 5 years. So after 5 years, each car is going to have a $9,000 value. On this problem here, it says the quantity supplied of a good is the amount of product that a company is willing to make available for sale at a given price. Quantity demanded of a good is the amount of a product that consumers are willing to purchase at a given price. So suppose the quantity supplied, which is S, and the quantity demanded, which is D, are given by these two functions, where P is the price in dollars of a smartphone. So this is the equation for the supply that will be produced based on a certain price. This is the equation for the demand based on a certain price. Okay, it says the equilibrium price is where S of P equals D of P. It wants us to find that. So when we come down here, all we're going to do is set S of P equal to D of P. We add this over and add this over. We get this here. So if I add the 3.75p over, I get 18.75p. If I add the 900 over, I get 37.50. If I divide 37.50 by the 18.75, we find out that the equilibrium price is $200. At $200, that's where the company is producing as many phones as they will sell. They won't have any left over, and they won't have a shortage of phones. If you look at the next two, next one says determine the price at which supply is greater than demand, and then we're not going to worry about the graph. So let's look at when supply is greater than the demand. Well, all we're going to do is the same equation, so we're going to put a greater than sign here. And so what we're going to find out is the price has to be greater than $200 if the supply, meaning we have a bunch of phones left over, is greater than demand. See, once that price of the phone goes up past $200, people aren't going to buy it because it's too expensive. And if you look over here, here's a graph of that. And here's showing that equilibrium point where supply and demand are equal to each other. In other words, the supply of phones we have is exactly what we need to sell. And then you can make judgments based on whether you want to increase the price. You're going to see that the demand goes down. If you decrease the price, you can see that the demand goes up. But as you decrease the price, the supply goes down. So it's kind of a catch-22.